All right, welcome back, ladies and gentlemen. So our next session is going to be with Major Patrick O'Rourke, who's actually going to talk about Geodesy and its support to fires. So as an Intel nerd, this is actually near and dear to my heart, so please.
Thank you, sir. As stated, my name is Major Patrick O'Rourke. I'm an artillery officer by training. Obviously, United States Army artillery. So, why Geodesy? I probably owe an explanation since it's kind of a very niche subject. So, when I was at Command General Staff College, I was actually an interagency fellow. So I was selected to go to the National Geospatial Intelligence Agency. I got a degree in Geospatial Information Systems, and I spent a year at NGA working with them essentially as one of their teammates, working in the Source Foundation Production Office. So what that's responsible for doing is producing all of our topographic maps, nautical charts, aeronautical charts, and as you stated, geodesy. So geodesy is a really interesting subject because it's often overlooked. It's very critical to all the things that we do. And there was an interesting, I guess I wasn't made aware of it until there was an issue that arose while, the last few months that I was at SFP. That was an issue that arose with the World Magnetic Model not being updated on certain topographic maps in the PACOM AOR. And it created compounding issues when you start looking at your various fire support systems that are supporting the warfighter, and if the observer's looking at something and it's a little off, and the gun line's shooting to support the thing and it's a little off with the magnetic model, and that creates some significant errors in range deflection. So I found that fascinating, and I reached out to some of my teammates over at Fort Sill, over at what was now currently cross functional team for long-range precision fires, and asked and inquired about the currency of some of the magnetic models and some of the other earth sciences. And I was surprised to find that there were a number that were a little out of tolerance, and a lack of awareness on how often things should be updated. Then also trying to find out, like, how do we ingest all the data and how to ensure that our systems are updated. So we kind of started a dialogue, and they were able to create a little bit more functionality and measures to ensure that stuff was currently updated regularly, and communicated across all their systems. So then, when I got here, I started looking at research to do, and I thought, how do we, if that's a problem for the creation of all this data and the compiling of it and getting it down to the user at a national level, down to a tactical level, one, how do we try to scale that down to where it's doable at a unit level? And then also, given that we're expected to operate in austere and often contested environments where we may not always have access, how do we make ourselves self-reliant? So that's essentially the thesis of my paper, is how do we make it to where we can organically produce these things? What technologies are currently being explored to where that's something that we can do in the future? Where do we currently stand now, and then how can we extrapolate that further on to make it to where every sensor, or every soldier can be a sensor, or Marine can be a sensor, or every firing platform could also do the same. Then there's also other element of that I thought, from an organizational standpoint, I didn't quite weave into my thesis, but it's littered throughout my paper that we'll kind of discuss at the end. So we'll jump on to the first slide there, where we discuss geodesy. So the definition is up there, where it just basically explains this earth sciences. It encompasses a lot of different things within NGA's geodesy department. They've been out in 6 different categories, and there's 13 subcategories. Coordinate reference systems, map datum, controlled imagery, earth models, precision navigation and timing, among other things. So there's a lot of different areas that this can go. So I chose 3 just to kind of keep it simple. I chose controlled imagery, I chose earth models, and I chose precision navigation and timing. Why? Because they're important to the fire support community, specifically those 3 areas. So, controlled imagery is not an easy thing to produce. All of these things are not easy to produce. They require a lot of resources. Okay. Those resources are in terms of time, exquisite capabilities, and the expertise to produce them all. For instance, controlled imagery is developed through two different data sets. One is exquisite snaps from a lot of our NTM overhead sensors. So it's not something that we can just kind of reach out and say, hey, I need a new snap of this area. You have to go through a process in order to get prioritized, in order to get all those different pictures, and then it's overlaid on a elevation model. An elevation model is produced in a different department, and it requires a number of different experts that sit there and validate height above ellipsoid and ensure that like what's been produced from the radar image is actually as it said. So that takes a long time. It's not something that's just done on the fly. It could take months to years, depending on the area that you're doing, especially when you look at more precise data sets like digital point positioning database, DPPDB, which is what we typically use in like some of our targeting software to ensure that we have height above ellipsoid. That also has a number of like little bits of metadata that are associated with it as well that have to be compiled. And then you look at the Earth models. In order to consolidate all that information, NGA doesn't own all of the sensors. They rely on academia. They rely on research scientists. They rely on some private industry through a network of various sensors that are across the globe to pull all that data together, compile it, refine it, make sure it's accurate, and then package it and then push it out. Those things take time. There's also a frequency of change. Gravity is a little bit more predictable. It's kind of like prevailing winds. If you think about weather, it sort of changes in a specific pattern. It's actually degrading over time, but very insignificantly. Whereas the magnetic model, and let me back up. So the gravitational model is something that we could do every 10 to 12 years. It used to be 12 years, now it's 10. So it's, again, predictable, so you can kind of see the trend that is going. People don't generally freak out when they, don't get an update. We can kind of fudge it a little bit. But the magnetic model is a little different. It's incredibly erratic. It's like weather in a mountain range. You don't know what it's going to be like day to day. And because of that, it's updated every 5 years. Sometimes, in fact, in 2019, they had a significant change in the magnetic model to where they had to push out an emergency, essentially, WMM. So all of these things take a lot of time, a lot of people to get them all together. And then package them and ensure that they're accurate and disseminated across the board. And then there's also things that can interfere with that. For instance, with controlled imagery, one of the things that I looked at was the use of deep fakes. If there is the ability of an adversary to get into the chain to manipulate any of the data to full sensors or full analysts. We don't always use our own overhead sensors to produce like the high quality image. Sometimes we use commercial imagery to do that. So there's a potential that an adversary could manipulate some of the data that would be, that could, prevent us from having accurate, controlled imagery to produce that targetable data. And then the same thing with some of our sensors. If we can't get an update for WMM or the Earth gravitational model, EGM, then that could cause issues. So if we're in a very austere location, if we don't have connectivity, then there could be issues. So how does this rely, or how does this pertain to the fire support system? So I looked at it through the lens of the 5 requirements for accurate fire. This is near and dear to every artilleryman's heart. This is ingrained in us from the beginning, so it breaks it down into target location to size, firing unit location, weapon and ammo data, meteorological information, and computational procedures. Those are the 5 requirements. So each one of those, with the exception of weapons and ammunition data, uses some element of geodesy. So those that are viewing the slides, look at the bottom. There's the list within each one of those little bins that shows the data is required for us to process fire missions across the fire support system in order to ensure accuracy. So the point being is that if we don't have accurate data, then it will prevent us from being able to shoot effectively and accurately. So I then looked at what things may exist in the future or currently that we can either build on or continue to develop that may be ways of ensuring that we have accurate stuff. So I've binned it out in three different ideas. So within looking at controlled imagery, Earth models, and precision navigation and timing, I looked at each one of those systems through another lens of production, dissemination, and then the management of data. Okay. So looking at production, what systems or sensors exist today or have been used in the past or recent past that we can build on. So there was a program that the Marine Corps actually used in Afghanistan called FMV-V1. So it used, your organic UAS sensors off of essentially an MQ-1, okay. And it produced targetable imagery. Once they were able to understand the parameters of flight data, establish certain standards for, wind conditions, elevation, etc., and then also the requirement to have two systems simultaneously snapping the same thing to produce a near pair. Okay. So I thought, if that's a capability that we can use today, maybe it's been developed or refined over time. So I went down to NGA, because it's just up the road over Springfield, and talked to some of my peers from my time in 2015. And there's currently a program that is unclassified that was kind of interesting. They were able to produce DPPDB targetable data off of a cell phone. Gentleman had developed the technology, flew out of Reagan, and recorded downtown DC with his iPhone. Wow. Full video, and then took it back and was able to produce DPPDB snaps that could be used. So if that guy could do that, could we not power that down to soldiers? Maybe they don't need to do full video, but they could do simple snaps of images, have two soldiers taking a snap of the same thing, and that's not going to require a whole lot of data, because these things are kind of dense in terms of the amount of data that it'll require on your computer. For instance, when I was at Fort Bliss, we had asked for the impact area to be reproduced for DPPDB, and it's maybe like a 70-ish square kilometer area, and it was like almost a 10. Wow. And it was full brick. That's how it was disseminated. They just mail you a brick. But if it's just two soldiers with some sensor capability, I know we've tried to move to a Net Warrior where everyone has a little phone that can do mission planning and call for fire, laser designation and such like that. Why not do the same with two images, small data, back to the FTC or the Fire Sport Coordination Center, and they can use that to produce targetable data. Okay. So that's one aspect. The other is, how do we self-locate? How do we get away from relying on years of production for magnetic models, gravitational models, and how do we ensure that that can be produced at the unit level? So there were two areas that I looked at. One was a sensor called a diamond magnetometer, which uses a cubic zirconium, so an artificially produced diamond that allows exquisite very precise, to the location. It doesn't produce a whole magnetic model. It just allows you to produce a magnetic model for your immediate area. Oh, okay. So essentially, it gives you magnetic north from where your location is without the ingest of external data. And right now, it's being developed by Northrop Grumman, and it's about the size of maybe a football, we'll say. So it's scalable, and it's not really that expensive right now, considering that they're using artificially produced diamonds. It's not like we have to go to Africa and dig them up and all that other stuff. So that's one option. The other that one of my peers during our dialogue on our future war papers brought up that I've been exploring recently is the use of autonomous LiDAR sensors. So UAS with a LiDAR sensor to do survey in the immediate area of your gun position. That way, it doesn't require a soldier to do any of the manipulation of the drone or drones, and it produces high quality unit location that we can use to fire off of effectively. And then with precision navigation and timing, I think almost, I imagine, every future war paper student or class, or sorry, every academic year does the same thing where somebody does a paper on like contested environment and GPS. So how do we get around that? One of the things that I considered was, back to my training as a young lieutenant, was the use of celestial navigation. The Kolchak Polaris method wasn't really taught to me in the schoolhouse, but any smoker gunny down at the gun line that's worth his salt knows how to do that. And you usually take the young lieutenant out to show him, like at night, how to navigate, do self-location off of celestial bodies. So that was using a lot of old technology. Your aiming circle, your compass, all the just recognition of the night sky. So clearly we have done better since the past, and we have, like, there are sensors now that can auto develop self-location.
Okay.
That can help somebody identify where they're at based on position without having to know all that stuff and those techniques. So the idea is scaling some of this down to the level at which it can be placed on each one of the platforms, and then that leads to the dissemination part. So if we can get each one of the firing platforms to pull self-location, to pull magnetic model, or not magnetic, the earth science data to help with self-location, then how do we share that? Because it's good for one system, but we kind of have more than just one piece generally. So I looked at wire mesh, or sort of wireless mesh networks, kind of like what I think Ryan had talked about earlier, alluded to, where a number of different sensors can share data almost autonomously, where it can bounce back and forth. Then I also looked at, but not in as much depth as he did, but the use of blockchain and using almost like a non-fungible token, like methodology to sharing some of these data packets, so it can be secure and unlikely to be influenced by outside elements. And then that kind of led to the management. How do we manage the data? Because again, as I said, with like DPPDB, it's very dense. It's not easy to disseminate. It takes up a lot of space. So between like either distributed server platforms and each one of the firing unit locations, or on the platform itself. But then I also looked at compression of the data. So that was one of the things that we had looked at with NGA, was how do we take all the topographic data, we make it into like various layers of raster, and then compile it into a smaller packet. It does take a lot of work. It's not an easy thing to do. It's also a lot of stuff that I don't quite understand because I'm not a computer guy. But I found it very interesting, especially if we tried to do it at scale and not worry about having all the data, but just the data that we need for the particular area. It could be usable to ensure that we have all the things that we need for whatever mission set. And then the other thing that I looked at was probably, or I think would be controversial within the fires community from a organizational standpoint. And it's actually the title of the paper is the 6 requirements. So as I said, 5 requirements of accurate fire. Perhaps one way of reframing is viewing all the geodetic data as a 6 requirements.
Okay.
Because each one of these, there is a very detailed sort of checklist that every fire direction officer will go through in terms of like the quality of the data. Do they have the data, and whether or not it's sufficient to shoot off of, or what is the risk if you do shoot off that data? So when you look at target location size, is it a map spotting? Are you actually pulling it from a dagger or plugger? Same thing with firing unit. Is it surveyed in, or are you just doing it off of a map spotting? Like map spotting, obviously, it's not really that safe, or it's higher risk.
Yeah.
But if you have more exquisite data, then it's good. You want to get all the checks in the green category to say, like, yeah, we're shooting very accurately off of all the fire requirements. But I think with geodetics, I think we need to reframe it and think of it more as a 6 requirement. We need to look at like the quality of the data that we have. And there's even some things within computational procedures that I think could kind of fall into place with that too, but that's a subject for another time. But that was generally the direction that I was going with this, was, how do we power this down to the organizational level, make the sensor smaller, and then is there room within the fires community to think of this differently in an organizational standpoint?
I think that's a lot. I can think of a lot of geospatial intelligence Marines that are probably ecstatic to hear this type of information and to add this as a thought process, all right, as a recommendation for the firing or the artillery community and the fires community. So I think that's very exciting, actually. And the recommendations, I think, make a lot of sense, right? As we build edge processing capabilities, we build sensing capabilities, as you talked about, everything becoming a sensor and allowing or contributing to the processing and understanding of the environment. I think that makes a lot of sense. Well, thank you very much. I appreciate you coming and talking to us about this, and appreciate the recommendations that you have. I think make a lot of sense, and I hope that some of those will get represented in the fires community, and I'm sure you'll have proponents. If you can marry up with the intelligence community, right? You already have your network in NGA, but you also have quite a few Marine, again, geospatial intelligence analysts and specialists who I think would be happy to help champion this. So please reach out to us, myself, or the Krulak Center, and we can try and see if we can link this up and make some of this stick.
Absolutely.
All right.
Thanks, sir.
Thank you very much.
Education is what's important. Training, preparation for the expected. Education, preparation for the unexpected.